Alrighty guys, so here's the second part of the matrix videos I'm making for class. I am driving in a car. I'm not actually driving right now. I'm a passenger in a car, so all the noises that you may hear, who knows? We'll see how it works out. Alright, this video is for the second page of our notes, which is on inverses. So you can flip open to that and we'll get going. Alright, so you should be on this page of your notes. And the one thing that changes is yours says multiplicative inverse. The first thing we're going to do is the multiplicative identity for real numbers. And I want you to check out the second sentence. We have A times what gives you A. So a number times what will equal itself. Hopefully you're thinking 1 right now. Right? That's our multiplicative identity. Different for addition, right? The additive identity would be 0. But just like addition and multiplication, for matrices, we also have an identity, and that's this guy over here on the right, our identity matrix. So this is just an example of one, and it's labeled IN. If we wanted, for example, the identity matrix I3, that would be a 3 by 3 square matrix. So our identity matrix, or for matrices, the multiplicative identity has to be a square matrix. So I'm writing out our multiplicative identity here. That would be our 3 by 3 matrix. So anytime you see this matrix multiplied by any other matrix, so here we have a 2 by 2 times a 2 by 2, we should know that our answer is going to be that original matrix given. So in this case, 5, negative 2, 3, 6. So you can surely go through the whole process of our row by column multiplication if you want, but not necessary, since that's just our multiplicative identity. Okay, so moving on from the identity, the next blank we have down here is for our multiplicative inverse. So for example, think about if I have, let's take the number 5, and I want to multiply 5 by something to get 1. Hopefully we should be thinking 5 times 1/5 equals 1, and that would be the multiplicative inverse, right? Which we know is just taking a reciprocal. So for non-zero real numbers, a times the reciprocal of itself, 1 over a, would give us 1. Remember, another way we can write this is a to the negative first power. So just like we had an identity for matrices, we also have inverses for some matrices. So a couple key things. We can only have an inverse for a square matrix, and we write it just like we have above, so this a to the negative first. So if I have a matrix A, and I multiply it by its inverse, or the reverse, its inverse times A, we should get that original identity matrix that we just talked about up top. So I want you guys to try out these examples, number 3, A and B, and we're trying to figure out if these are inverse matrices. Okay, and to do that, you are just going to multiply the two matrices. And hopefully, if they're inverses, we will get the identity matrix. Alright, so give it a try. You can pause this video. I will put the answers up and double check if what you got is right. Alright, so I showed a couple steps for the first one here. I did the row by column multiplication, and hopefully if you did this, you saw that it worked out to be 1, 0, 0, 1, which is our identity matrix, which means these two matrices are in fact inverses. Alright, for B, I don't have to go very far, because if you multiply the first row and the first column, we're going to get a 2, and our first entry has to be a 1 to get the identity matrix. If you went all the way through to multiply this, you should have gotten 2, 0, 0, 2, which even though it looks like it's the same form as our identity matrix, right, it doesn't have that diagonal row of 1s there, so that one doesn't work out. These matrices are not inverses of each other. Okay, so a couple facts about inverse matrices. If a matrix has an inverse, then we call it an invertible matrix. I'm going to actually skip the next blank and go down to the second line, if a matrix does not have an inverse, we call it a singular matrix. Meaning there is nothing that we can multiply it by to get that identity matrix that we would be looking for. So kind of in line with that, on that note, if a matrix is invertible, we call that non-singular. So if a matrix does not have an inverse, singular. If it has an inverse, non-singular. Okay, so we're going to move on to actually finding an inverse now. I'm going to create a new page here just to go down to the next example, number 4. And we're going to figure out how we can actually figure out what an inverse of a given matrix is.